Welcome back everyone. Let's start today's class. Today we will finish this chapter. Okay, now we will learn how to balance chemical equations. Okay, here we see A and B are reactants and C and D are products. The left hand side is reactant side and the right hand side is the side of the products, right? Okay, then balancing such type of chemical reactions means number of atoms of each element of reactant equals to number of atom in the product, right? Means all the atoms present in the reactant will be equal to the number of atoms of the product. To balance this equation, we have to maintain the law of conservation of matter. Let's check the law of conservation of matter. What is this? Matter is neither created nor destroyed in the course of a chemical reaction, right? Means the matter will be constant. It neither created nor be destroyed when the chemical reaction is going on, right? Here, to balance a chemical reaction, we have to follow two types of methods, and they are: number one is heat and trial method, and number two is partial equation. Okay, now we check what is heat and trial method. Here, heat and trial method is: number one, we have to firstly count number of atoms of all elements on both sides, reactant sides and product sides. Let's check with an example. Here is an example. We take Fe plus H2O gives Fe2O3 plus H2, right? Now we count number of atoms, and here we get Fe is 1 in the left hand side, hydrogen is 2 in left hand side, and oxygen is 1 in left hand side, right? On the other hand, we can clearly see that at right hand side Fe is 2, hydrogen is also 2, and oxygen is 3. Okay, now the second point of heat and trial method is to multiply Fe on the left hand side by 2. Okay, multiply the Fe on the left hand side with 2. Number 3 point is multiply water on the left hand side by 3. Okay, then to balance hydrogen, here we put 3, and then hydrogen is now 6, 2 into 3. So to balance hydrogen on right hand side, we have to multiply 3 to become 6. Okay, and finally the overall balance reaction is we get what 2Fe plus 3H2O equals to Fe2O3 plus 3H2. Okay, let's check what is partition equation. Partition equation, here we take an example of oxidation of lead sulfide by ozone, that is O3. Okay, firstly here we see O3 decomposes to O2 and O. This is nascent oxygen. Okay, oxygen molecule plus nascent oxygen from ozone. After decomposition we get this 2. Secondly, we can see PbS plus nascent oxygen reacts and gives PbSO4. Okay, and thirdly we combine this 2, and after balancing oxygen multiplying by 4 both sides we get this, and then we rewrite this equation again, and this 2 equation gives us this overall balance reaction. Here the 4 nascent oxygen on the right hand side and 4 nascent oxygen on the left hand side, they are cancelled. Okay, then we get the valence reaction as PbS plus 4O3 gives PbSO4 plus 4O2. Okay, now here is some information about nascent oxygen. What is this? Now this is highly reactive. Okay, this is toxic because it can damage our DNA, and it is an oxidizing agent. Okay, thank you for watching this.